We propose TiltChair, an actuated office chair that physically manipulates the user's posture to address problems associated with prolonged sitting. The system controls the inclination angle and motion speed. It can cover a wide range of posture guidance contexts, from a subtle guidance that weakly motivates minor posture changes to a physically intrusive guidance that forces the user to stand up. TiltChair has an inclination mechanism beneath the seat surface. Seat inclination is achieved by pumping air into an inflatable component. This is system overview of TiltChair. The arrow lines indicate serial communication, and the blue lines indicate airflow. Inflation and deflation can be switched by controlling the hand valve with a servo motor. The air inflow is controlled by rotating a dial on the regulator with another equivalent servo motor. We investigated the effects of the seat's inclination angle and motions on task performance and overall sitting experience through 2 experiments. In Experiment 1, participants were asked to perform a desk work task under different static seating angles. The seating angle tested was set within the range of 0 to 40 degrees at 5-degree intervals. Experiment 2 involved a desk work task similar to E1, while several different patterns of inclining motions occurred on the seat. Participants were presented with a total of 11 conditions, which consisted of a combination of the 5 motion speeds times 2 arrival angles plus a static condition with no motion. Please see the paper for the results of these experiments. A representative application is to break up prolonged static sitting to ensure well-being in office work. When the system detects a specific period of continuous seating, it slowly inclines the seat so as not to surprise or distract the user. When the user is more likely to tolerate interruptions, a more forceful inclination can be presented. Another example is a schedule notification application that prompts users to leave their seat. When the time approaches for the user to leave his seat due to an upcoming appointment, the system inclines the seat at an immediately perceptible speed. This behavior would make notifications more noticeable than visual notifications. The third is to implicitly represent the time limit of a task based on the fact that task performance improves under a certain time pressure. As the system slowly increases the inclination angle of the seat until the time limit, the user would feel time pressure as physical stimuli, which might improve task performance. The paper also discusses other application examples along our design space.